about these angles we talked about yesterday that you don't know yet. And because I don't have enough protractors, we're going to measure it together. So I'll put the protractor, you'll decide as a group on the different angles. So the first diagram we're going to measure is the central angle first. Central angle starts at the circumference, goes to the middle, and goes back to the circumference. So in the first diagram, either COA or OAC is going to be the central angle. Tell me in the second diagram which is the central angle. TOS or? And in the third diagram? So we're going to measure all of those first. I'm going to turn my paper just so it's at the bottom. Zoom in so you can see it. Offer 130-ish. We happy with 130? Okay, what do you think the second one is? Okay. Oh, yeah, wait. Ooh. 118, a little bit less than 120. Last one, who wants to guess? 110. Okay, so 130, 118, 110. Now we're going to measure the inscribed angles. What makes an inscribed angle an inscribed angle? Doesn't touch the middle, 3 points on the circumference. So name me the inscribed angle in the first diagram. Yep. The second diagram? The third diagram, there are two inscribed angles. I want the one that starts and ends at the same spot as the central angle. CBA or ABC. Okay, who wants to guess? 72. Any other guesses? 50. 65. I don't think it's quite 60. I'd say 59. It's not quite on the 60. 59. Oh, you can't see the angle there. 55, in between 50 and 60. Okay, so just saying them again. In the first diagram, the central was 130. The inscribed was 65. Second diagram, central 118. Inscribed 59. Last one, central 110. Inscribed 55. Turn and talk. Figure out the relationship between the inscribed and the central angle. No bouncing the apple or I take it back. Haven't heard anybody say it yet.
If you divide the central by 2,
She's got it. Take a look. What's 130 divided by 2? 65. What's 118 divided by 2? 59. What's 110 divided by 2? High five to Jess. Here's circle property number 1. An inscribed angle is blank the measure of the central angle. Half. Or we can flip it around and say the central angle is something the measure of the inscribed angle. Double. The key for both of them is they have to end and start at the exact same points. So if we look at this diagram, this property has nothing to do with this inscribed angle over here, A to D to B. Why? It doesn't end and start. How many of you are Star Trek fans? Nobody? Nobody's seen the last Star Trek? Oh my God, you have to watch the movies. They're so good. Anyway, I call this the Star Trek property because this is their little logo on their suit. Looks like this. I call it also the arrowhead property, so you'll hear me say both of those. So anytime you see an arrowhead or you see what I call the Star Trek logo, it's going to be this property. Just to prove that it doesn't matter what angle we have, take a look at this diagram. So if we took 95.63 and divided by 2, we would get... And just watch when I move this inscribed angle, it doesn't matter where it is. It's still going to be half that central angle. It doesn't matter even if I flip to the, well, there it flipped because it's 189, but if I come really close, doesn't matter where I put it. Take a look if I start moving the central angle, so I'll make it smaller first. What's happening to the inscribed angle? It's also getting smaller, but it's also always half. Even if I make the central angle really wide, what do you notice about the inscribed? It's always going to be half. It means that one is double the other or one is half. Doesn't matter where I put this. If I put it right on the diameter, what do you see up here? Right? Doesn't matter where I put that inscribed angle. Doesn't matter, it's still going to be 90 degrees. Circle property number 2. Here we're going to measure 2 inscribed angles. The first one's going to be A to D to C. A to D to C. Second one is A to B to C. And you notice both these inscribed angles have the same starting point and the same ending point. In the second diagram, we're going to measure A to D to C. And the second one is A to B to C. Again, you'll notice they have the exact same starting and ending point. How do you know they're going to be the same?
It looks the same.
So look at the orange.
50.
Agree, 50? 50, okay, write that down.
For which one?
It's for the orange one.
So ABC.
ADC.
Oh, AB, sorry.
And here I'll do ABC. What do you see?
50, 55.
What was the other one? They were supposed to be the same. My lines might have been out. Yeah, I'm a little bit out there. Let's pretend it's 50-ish, because they're supposed to be the same.
I think it's because like the other line's really thick.
Yeah, it's hard to measure when it's so thick. 51. Oh yeah, you're right. No, that's the protractor. There we go.
Oh, that's like 50.
There, 50 on the nose. See if I do a good job of the thick one. 50.
It's the same shape, it's just turned.
I call this one the bow tie. So you'll hear me say Star Trek or arrowhead and bow tie because you have to start looking for the shapes. Star Trek or arrowhead, the central angle is double the inscribed. What happens with bow tie? They are equal. just to show you here. You notice with bow tie, the center is irrelevant. It doesn't have to go through the center. It might, but it might not. The center is not important with this. Take a look as I change this inscribed angle. What do you notice? Stays exactly the same. What if I change this one? Stays exactly the same. How I'm going to make them bigger is by changing the starting and end point. If I make it smaller, look what happens to both of them. If I make it bigger, look what happens to both of them. But they're always going to be the same. What you have with bow tie property is actually 3 sets of equal angles. So if we look at the top, we have equal angles, but we also have equal angles at the bottom. What do you remember yesterday about an X? We talked about intersecting lines and an X. What do you remember yesterday about the X? Yes. Tell me about an X. So you also get corresponding angles here. So what happens is you get 2 triangles with all the same angles. The top will be the same, the bottom will be the same, and the 2 across from the X will be the same. Questions so far? All we're going to do is use these 2 properties to answer a bunch of, oh, there's one more line, there's one property I forgot about. Ah, drop my protractor. We're going to measure BAC and BOC. So BAC I'll do in blue. BOC, straight line. This is actually the same as Star Trek property. We actually showed it with the diagram, but I'll do it in a second. What do you know about the line BOC? What will we call it? It's the diameter. What's the measure of the diameter? Has to be 180 degrees because it's a line. Why? Because it's half, so it's actually property number 1. Second diagram. 90. Well, I'm also going to color this part of the circumference. What did we call that yesterday? So inscribed angles in a semicircle are right. That doesn't mean right as in right versus wrong. What does a right angle mean? 90 degrees. So I call the properties arrowhead or Star Trek, bow tie, semicircle. And semicircle really just is arrowhead. It's just a special case. So all the questions in this unit are going to look like this. They're going to give you some funky diagram. They're going to give you some information. They're going to ask you a question. And all we're going to do is use the protractors. What you need to know is none of these questions are ever going to be drawn to scale. So it is not going to help you on the exam to bring a ruler and protractor and measure. That's not what this is about. It's knowing the properties and how to apply them. Okay, so these are never, ever, ever drawn to scale. So where do you start? Well, start by labeling what do we know? What are we given in the question? Where is 80 on this diagram? What kind of angle is it? It's a central angle. How do we know it's a central angle? Because it goes through the center. And how do we know it's the center? Because O is the center unless they tell you otherwise. So anytime you have an O, it's always going to be the center. So this is going to probably have to do with property number 1. Explain how you can determine the measures of A to C to B and A to D to B. So let's do A to C to B first. Explain needs in words. How can we find the measure of this? Multiplied by 2 or divide by 2? Why do we divide by 2? Why? What's the actual property I'm getting you to say? Flip back to the box and read me what the property is.
Inscribed angle is half the measure of the central angle.
That's your reason why. Because inscribed angles are half the measure of because inscribed angles are half the measure of the central angle, we divide by 2. So part of your explanation should always repeat back the circle property. To say we divide by 2 is not enough. You're not telling me why we divide by 2. So always just repeat back the circle property. Okay, what about the other one? A to D to B. It's the same. It's 2 star tracks or 2 arrowheads right on top of each other. What are their measure? 40 degrees. Why 40? 80 divided by 2. Questions so far? Anytime it's asked to explain, repeat back the circle property. Example number 2. O is the center of the circle. AO is 5. AB is 6. Find the length of BC. Start by labeling what do we know? Well, we know A to O is going to be 5. We know A to B is going to be 6. When we don't know something, what do we typically put in math? So let's put an X on BC. After you've labeled, think of the shape. Is this arrowhead? Is this bow tie? Or is this semicircle? How do you know it's a semicircle? Because it's half of the circle because this is a diameter. I'm a visual person, so I highlight the shape. If that does nothing for your brain, then don't think you have to. What is the property we know from semicircle? This is a right angle triangle. So really the fact it's a circle now is irrelevant. We have a right angle triangle and we need to find one of the sides. This is why we reviewed. So if you're not sure, flip back to the first 2 pages. What had to do with a right angle triangle on those first 2 pages? Which is a squared plus b squared equals c squared. Now be careful, you're not just going to throw 5 and 6 into the formula. We need this entire side for one of the side of the triangle. That's the hypotenuse. What's its length? How do you know? Because half is 5, the whole thing has to be 10. Do you see how we're using a lot of logic behind this? Right, just what we know about circles. So we can call A X, B would be 6, C would be 10. Bed mass, what do we do first? Don't have any. What comes after B? Exponents. Now this is just an equation back from Unit 4. How do we get rid of plus 36? Offer of 64. Sounds like confirming of 64. What's the opposite of squaring something? Units. And I'm just going to highlight the units so you remember you have to include them if they're given in the question. Questions so far? Nope. A and B you could switch. So like I said yesterday, these aren't questions that I can give you a method and I can say step 1 do this and step 2 do this because they're all different. Here's general hints. Step 1, label what you know. Look for the shape. Is it arrowhead? Is it bow tie? Is it semicircle? From the shape, you're going to get the property. The property is going to give you some kind of information to solve the question. Following diagram for 3, 4, and 5, C is the center of the circle. Okay, example 3 gives us the radius is 6. Where would you want to put this radius? And there actually was supposed to be a B over here, but it got cut off, so let's add it on. What else is also 6?
C to B.
How do you know?
That's the same one.
Because they are equal
Radii.
equal radii. Well, right away, even without looking at the rest of the question, what kind of triangle do we have here? Not what property, what kind of triangle is this? This is isosceles. How do you know it's isosceles? 2 equal side. Because of this shape, what's it probably going to have to do with? Probably arrowhead. B to A to D is 40. So start at B, go up to A, go to D. Top of this diagram has to be 40. I'm going to switch colors. Up to you if you want to join me. I like to switch colors because I like to have one color what was given and now another color just what we're figuring out from the circle property. Arrowhead. What do you know about arrowhead? What is half of what? Or what is double of what? The inscribed angle is half of the central. So just from the property, we know the central angle. What does it have to be? This diagram here, this little triangle is an isosceles triangle. What do you know about the 2 angles in an isosceles triangle? They're equal. So if we look at this little triangle, we've already used 80. How much is left in the triangle? 180 is the total. If we've used 80, we have 100 left. How much do these 2 angles have to be? 50 apiece. I haven't even looked at what the question is asked yet. I just know that from what I know about triangles and circle properties. So I'm just going to make a note. The 50 came from 180 minus 80, which was 100 left. And we divided by 2 because it was isosceles. Again, I haven't even read what the question asked. I just know these because what we know about triangles and circles. So I started with the arrowhead, and we know if the top is 40, the bottom or the central has to be 80. This is an isosceles triangle, and if I've already used 80, I have 100 left. 100 divided by 2 has to be 50. Okay, find B to C to D. Did we already find it?
Yeah.
What's B to C to D? Did we find C to B to D? What is it? Did we find C to D to B? What is it? 50. Questions so far? Do you see how they're little logic problems? Right? You're just using what you know about circles, using the values to figure stuff out. Same diagram, but we're going to switch up the numbers now. Now they're telling us BAD is 45. If the radius of the circle is 8, find the length of the chord B to D. Thoughts? Why does the central angle have to be 90? You keep switching that. It's double. So I'm just going to redraw just that little triangle in the middle. This is B, and this is C, and this is D. We know from arrowhead that this has to be 90. We know the 2 equal sides because their radii are 8. What does the question want us to find? The distance from B to D. How do we find it? It's a right angle triangle. A squared plus B squared equals C squared. Go ahead and find BD. 64 plus 64. Offer of 11.3. Confirm. Not really hearing confirmation? 11.3, what now? Questions so far? Same diagram. If BAD, so now the top of the circle is 2x minus 5. What? What's this x thing? Hello, algebra, you're back. And BCD is 8x plus 7. Find the value of x. Okay, well, what do we know about BAD and BCD? So 2x minus 5 equals. Now the hardest thing is, where do we get the 2? Does the 2 go on the left or does the 2 go on the right? Well, if you look back at the original numbers, this was 80 and this was 40. How do we make those equal? So do you want the 2 on the left or the 2 on the right? Because I've heard both now. Confirm? So 2 times 40 has to equal 80. The other option is you can put the half on the right. You can say that 40 equals half of 80, completely up to you. Okay, this is just an equation from Unit 4. What was step 1 to solving any equation? Brackets first, what do we do? What's the word? 2 times 2x? 2 times 5? On the other side, ax plus 7. 8x over, how does it move over? At the same time, if we want to move the negative 10, what do we do? What's the last step of every equation we ever solved in Unit 4? Can we divide evenly? Can we reduce it? What do we do? Just leave it. Questions? You can, yeah.